Imagine a time when Earth's air was so rich in oxygen, dragonflies grew as large as hawks and giant bugs ruled the land. The oxygen-fueled world was one of immense creatures and explosive changes. Armored insects with wings as wide as your arms buzzed through lush fern forests, while towering reptiles took their place as the planet's new rulers. Wildfires sparked as the air, thick with energy, turned forests into blazing infernos. The land itself was constantly shifting. Dry winds and torrential rains reshaped everything in their path. This was Earth during the late Permian, over 260 million years ago, a world where life thrived like never before. So, welcome to Whisper of Time. I hope these stories help you relax or whatever, but before we get started, hit the like or subscribe button. And hey, I'm curious where everyone's from. Comment your city and time. It's my pleasure to connect with you mentally and emotionally as we journey through the past together. By the late Permian, Earth's land masses had locked together into Pangaea, a single giant continent stretching from pole to pole, its heart a vast stretch of land where the sun bore down relentlessly. Seasonal rains lashed the coasts, driven by strong winds sweeping across the equator. But deep inland, the air grew still and harsh, transforming vast expanses into dry, cracked deserts where dust storms whispered through the earth. To the south, Gondwana held thick forests ruled by Glossopteris plants, their broad leaves reaching a full metre long, forming tangled groves that trapped moisture and shaded the soil like silent guardians. To the north, Laurasia showed red beds of sand and silt, layered from ancient rivers and floods, painting the landscape in rusty hues under a relentless sun. Plants adapted to this changing world, with seed ferns like Glossopteris spreading wide roots to hold water in tough times, their seeds tough enough to wait out dry spells. Glossopteris, with its wide-reaching roots, dug deep into the dry earth, storing water like a hidden treasure, while its seeds lay dormant, waiting patiently for a break in the arid landscape. Chordate stood tall as conifer-like trees, some growing 30 meters high with straight trunks and needle leaves that shed less water than older forms. Leucopsids, once rulers of wet grounds, faded back, their spore-based ways giving ground to new gymnosperms carrying seeds protected in cones, ready for winds to carry them far. No flowering plants existed yet, so the land stayed locked in greens and browns, with seeds evolving thicker coats to survive the growing aridity. Ecosystems shifted from soggy swamps to open woodlands, where trees spaced out across hills and valleys, leaving room for winds to carve invisible paths in the dry air. Coal is still built up in pockets, pressed from dead plants in low spots like those in eastern China and eastern Australia, where layers of peat turned to black seams over time. These spots held on as wet refuges, but overall the land dried, with rivers carving deeper channels and soils hardening under the heat. The air carried 30% oxygen, based on models like Berner's geocarb sulf, which tracks levels from 25 to 35% in the early and middle Permian, holding steady near 30% by 260 million years ago. This extra oxygen made fires burn hot and fast, with fossil charcoal scattered in rock layers showing frequent blazes, as noted in geology journal studies from sites in Gondwana and beyond. Carbon dioxide hung at 400 to 800 parts per million, mixing with oxygen to trap warmth and fuel greenhouse air that baked the interiors. Marine rock isotopes, like Delta-13C and Delta-34S, back this up through sulfur cycle shifts, where buried sulfur and carbon kept oxygen high by locking away elements that would otherwise pull it down. Even with oxygen slightly lower than its 35% high from the Carboniferous, it was still enough to support the growth of giant insects and reptiles, whose size pushed the very limits of possibility. Backboned animals stepped up, their lungs growing better at pulling in air, with folded insides for more surface to grab oxygen, letting them roam farther from water and claim dry lands where older forms struggled. If this glimpse into a forgotten world left you wanting more, let me know in the comments. Your thoughts could inspire others to join and keep these ancient stories alive. Arthropods pulled oxygen through a network of tiny tubes called tracheae, which branched out like roots in soil, getting smaller as they spread deep into body tissues. These tubes opened to the outside through holes named spiracles, letting air flow in passively, moving from high to low spots. Efficiency came from how the branches split, with each level doubling or tripling to cover more ground. But size had its limits. Oxygen could only travel so far before fading out. The rate of spread, according to Fick's law, depended on the oxygen gap, tube wall area, and thinness of barriers, all divided by distance. In Permian air at 30% oxygen, this law pushed limits, allowing bodies to grow 20 to 30% bigger than today, as shown in models mapping fossil shapes and tube prints. These models, based on scans of ancient exoskeletons, showed how extra oxygen filled gaps that would choke smaller creatures now, letting legs stretch longer and wings beat stronger without starving inner parts. The air's gift came with a quiet cost, though. A body too large risked slow healing or weak spots if tubes failed, tying survival to steady high levels that the era held firm. Yet arthropods clung to this edge, their forms a record of breaths taken in a world that rewarded scale but punished slips. Vertebrates stepped into this setup with their own tools, amniotes leading the way through lungs that folded and looped to grab more air per pull. Synapsids like Dimetrodon, with its tall sail for heat control, breathed through systems that mixed blood and gas in tight cycles, hearts pumping harder to spread oxygen wide. These lungs held chambers that expanded deep, pulling in volumes that fueled active hunts across dry plains. Modern crocodiles offer a close look, their lungs flowing air in one direction like a stream, boosting uptake by 50% over back-and-forth breaths in other reptiles, as lab tests track gas exchange under stress. Those rates climbed sharply in high oxygen, mirroring how ancient synapsids likely handled Permian air, their rib cages wide for big draws that fueled chases and fights without quick tire. Circulatory paths in these creatures looped blood through lungs then body, with vessels thick to hold pressure, keeping tissues fed even in heat or motion. Fossils from Texas beds show Dimetrodon's bones dense with channels for fast growth, hinting at hearts that beat steady under loads that would strain lesser forms. This setup let them thrive where amphibians faded, their skin leaky and eggs bound to wet spots, while amniotes laid shelled young on sand and pushed into lands where oxygen's plenty turned breath into power. Tests at Arizona State University brought this back to life, raising beetles in tanks at 30% oxygen through the 2010s, where young grew 15 to 20% larger than those in normal air, bodies filling out with wider shells and stronger limbs. Dragonflies in the same setup stretched wings farther, their flight times longer in thick gas that eased the work of beating air. These runs, tracked over generations, matched fossil trends, with sizes peaking where oxygen hit highs, proving the link in living terms. Paleophysiological models built on these numbers estimated metabolic rates 1.5 times higher in Permian giants, energy burning quick for hunts or escapes, bodies running hot like engines tuned for excess fuel. These models, based on bone-thin sections and tube casts, calculated how fast reactions fired in cells flooded with gas, turning food to motion without waste. Yet the boost hit a fragile balance, rates so high that drops could stall life mid-stride, a shadow over the era's bold forms. Carbon piled up in seams across the Karoo Basin in South Africa, where plant remains sank into mud and pressed into coal over vast flats, locking away tons that kept oxygen free in the sky. These basins, fed by rivers from Pangea's edges, buried layers thick as buildings, with rates high enough to hold levels steady before the late drop. Sulfur isotopes in sea rocks told the same tale. Shifts in Delta 34S showing slow release from ground stores, a sign of stable air where oxygen resisted pulls from rust or rot. Records from drill cores in ocean floors traced this hold, with peaks matching coal builds until volcanic stirs began the slide. Your steps take you through a glossopterid woodland, where tall ferns rise around you like silent walls, their leaves broad and heavy, brushing against your arms as you push forward. The air at 30% oxygen fills your lungs with a light rush, a soft high that sharpens your senses but leaves a strange haze in your thoughts, as if the world pulls you into its grip. Charcoal scents hang thick from burned underbrush, remnants of recent fires that scar the ground, black patches crunching underfoot, a reminder of how quick flames can claim everything in this place. Winds whisper through the branches, carrying echoes of distant roars and scuttles, making you feel alone yet watched, the weight of hidden eyes pressing on your back in the dim light. Above, aerial hunters hold on from older times, griffin flies like Meganeuropsis cutting the sky with wingspans of 70 centimeters, their bodies sleek for dives that snatch smaller prey mid-flight. Fossils from Oklahoma's red layers preserve these forms, veins in wings clear as maps of their hunts, aided by air 20% denser than today's, per models that track how thick gas lifts heavy frames without strain. These flyers hover and twist with ease, their compound eyes scanning for movement below, a constant patrol that turns the open air into a field of traps, where escape means nothing if speed fails. On the ground, big arthropods crawl through the ferns, millipedes such as Arthropleura stretching up to 2.6 meters long, their segmented bodies coiling like armored ropes across the soil. Scottish fossils capture these giants in stone, plates locking tight for protection as they graze on fallen leaves, dozens of legs pushing them forward in a slow, endless march. Scorpions like Brontoscorpio lurk in shadows, reaching a meter from claw to tail, venom likely stored in glands behind their mouthparts, inferred from fossil jaws that show spaces for poison flow. These stingers wait in cracks, tails arched high, ready to strike at anything that stirs too close. Their presence a quiet threat that forces every step to carry caution, the mind always alert to the snap of hidden danger. Vertebrates rise in this mix, synapsids leading with Dimetrodon at 3.5 meters, its back sail of skin and spines catching sun to warm blood for quick moves in cool mornings. Texas redbed fossils show these sails veined for heat exchange, bodies built for ambush hunts where teeth sink deep into flesh. Early therapsids like Biamasuchus hint at future paths, their skulls blending reptile strength with mammal-like jaws, teeth sharp for tearing, legs sturdy for chases across open ground. These forms carry a raw drive, instincts honed by endless cycles of hunt and hide, where weakness means ending and survival etches deep marks on the spirit. In water edges, amphibians hold ground. Eriops at 2 meters long lurking in streams, its twisted teeth like mazes for trapping fish in strong bites. Eurypterids fade but linger, Campylocephalus from Russian sights gliding through shallows, paddles sweeping for small catches, their armored tails a last stand against changing tides. These water dwellers face growing pressure, their lives tied to wet spots that shrink under dry winds, a slow squeeze that builds tension in every breath. Permian standouts graze the lands, casids like Cotylorhynchus swelling to 6 meters, barrel chests wide for plant-filled guts, Oklahoma fossils showing short limbs for steady walks through brush, parareptiles such as Paraeosaurus armor up at 3 meters, thick plates shielding sides as they crop low greens in South Africa's Karoo fields, heads low and heavy, eyes watchful for threats that circle unseen. These herbivores move with a heavy calm, but underneath lies the pull of constant guard, the mind locked in patterns of eat and evade, where open spaces breed a quiet fear of what waits beyond sight. Fossils paint this world clear, sites like Richard's Spur in Oklahoma holding mixed bones from small to large, caves filled with remains that show crowds of life in tight spots before floods sealed them. Chinese Lapingian rocks layer diverse forms, from tiny insects to big reptiles, a snapshot of plenty right before the fall, with prints and teeth telling tales of daily struggles etched in stone. Gigantism drew strength from oxygen's hold, bodies scaling up to fill spaces where air fed every cell. Yet competition pressed hard, vertebrates crowding out older giants with better hunts and hides. Amber drops trap insect clues, their sizes shrinking slowly as levels dipped, a gradual shift that forced forms to adapt or fade, leaving echoes of a time when scale meant power but carried the seed of its own end. If you're still here, watching, it means you're truly connected to these lost worlds. But if you're holding back from subscribing to Whisper of Time, can you share why in the comments? Let's keep these stories alive together. Arthropod shells gave them raw power, letting these creatures lift loads 800 to 1,000 times their own weight, much like rhinoceros beetles today that shove aside stones or rivals with ease. These exoskeletons locked joints tight for massive pulls, turning small bodies into machines of force that dragged meals or burrowed deep without breaking. In the Permian shadows, this strength meant survival in a land where every move carried risk, the mind driven by an endless urge to claim ground before others could strike. Vertebrates matched this fire, their bones telling tales through thin slices studied under lights, showing cells that burned energy faster than modern kin. Fossil cuts revealed hearts and muscles running hot, fueled by oxygen's abundance, where rest meant little and the body stayed alert, a constant hum of life echoing ancient fears of the quiet end. Food chains tightened in this era, with plant eaters pressing hard on glossopterids, forcing the ferns to build bitter walls in their leaves. Tannins sharp on the tongue warded off bites and slowed hungry jaws. These defences grew thicker over time, leaves toughening like silent armour against the grind of teeth, a slow battle where plants held back just enough to cede the next stand. Predators ruled the top, synapsids claiming kills with calculated strikes, their packs or lone hunts turning the land into a field of weights and lunges, where prey felt the weight of eyes always tracking, instincts locked in a cycle of flee or fight. This dominance shifted balances, with smaller creatures slipping into cracks, their lives a shadow play of hide-and-seek amid the giants' games. Fires swept through often, leaving charcoal streaks in buried mud, as paleobiology papers trace from digs in old beds, showing blazes that jumped from tree to tree even in damp spots. These burns cleared paths, scattering ash that fed new growth, nutrients soaking into soil to spark fresh shoots in blackened clearings. Yet they broke lands apart, fragmenting woods into isolated patches, where groups split and struggled alone, the air thick with smoke that choked breaths and hid dangers, turning safe groves into traps of heat and loss. Creatures adapted to this rhythm, some thriving on scorched edges where food sprouted quickly, others haunted by the crackle that signalled the end, a psychological scar etched in every wary glance at the sky. Eggs changed the game for animals, amniotic shells wrapping young in wet safety, letting parents lay them far from streams on dry hills where water no longer bound them. This freed reptiles to spread inland, claiming vast stretches of Pangaea where old amphibians clung to fading ponds, their lives tied to moisture that grew scarce. Plants followed suit, spores giving way to seeds in gymnosperms, tough packets carried on winds across open grounds, pollination happening through air currents that scattered life without need for rain or bugs. Cones hardened to guard these seeds, waiting out storms or fires, a shift that let forests rebound in new shapes, resilient against the era's harsh pulls, where reproduction became a gamble on the breeze, instincts urging spread before the land claimed back its own. Pangaea bones rose high as plates pushed together, lifting mountains that blocked rains and turned lush belts into dry wastes, winds howling through new gaps where water once flowed free. This uplift squeezed moisture from the air, leaving soils cracked and rivers thin, a slow drain that left creatures grasping for what remained, their instincts twisted by the growing thirst that gnawed at every root and vein. Oxygen slipped from 30% down to 25% by 260 million years ago, as revised COPS models track through buried clues, showing how less plant sink and more rot pulled the gas back into bonds that held it tight. Volcanoes in the Amatian traps added their roar, spilling 500,000 cubic kilometers of basalt across southwest China, floods of lava that baked the land and pumped carbon dioxide thick into the sky, warming seas and choking breaths in a haze that settled like a final weight. These shifts hit hard, sparking dual mass die-offs from 262 to 259 million years ago, as a 2023 geology study lays out from rock layers and fossil gaps, where whole groups vanished in waves separated by empty years. Glossopterid forests fell first, their wide leaves wilting under heat and drought, stands crumbling to dust as fires claim the rest, leaving bare slopes where shadows stretched long and lonely. Conifers stepped in, tough needles and thick bark built to stand flames, their seeds sprouting quick in ash beds, a grim takeover where the old green world faded into sparse groves that held less life. Echoes of loss ringing in the quiet spaces between trunks. Oxygen levels fluctuated wildly, with sulfur in rocks slowly releasing at first, then fast, marking the drop as air thinned and seas turned stale. Black shales piled in the South China Sea, layers dark with dead matter where oxygen fled the waters, turning depths into silent tombs for fish and shells, a spreading blankness that crept from coasts to open waves, pulling life down into mud that preserved their last forms. Creatures felt this creep, bodies weakening as breaths grew short, a psychological bind where the once free air turned foe, instincts urging flight to spots that no longer existed, leaving a trail of bones in the gathering dark. Reptiles spread wide into the Triassic ahead, their forms branching into new lines that filled empty niches with scales and claws sharpened for the lean times. Synapsids bent toward mammal ways, jaws strengthening and fur hints emerging in fossils, warm blood helping them endure nights that cooled sharp, a quiet evolution born from the crush of loss where survival meant shedding old skins for hidden strengths. Arthropods shrank to sizes we know now, wings folding smaller and legs shortening as oxygen's gift withdrew, bodies adapting to less by trimming excess, a reduction that saved lines but stripped the grandeur, leaving them to scuttle in underbrush where giants once strode. No high like that returned full, linen breakers set firm in soils by then, fungi and bacteria chewing through wood to release carbon back quick, blocking the old builds that pumped oxygen up. Termites came later, their guts full of helpers that sped rot even more, turning fallen trees to dust in months, a final lock on the cycle that kept air balance low, where peaks stayed dreams of a buried past, and life moved on in tighter bounds, haunted by the memory of what abundance once allowed. Lignin stood as wood's tough backbone, a chain plant built to stand tall against winds and weight, but Permian fungi cracked it open with ease, Basidimer seats weaving through fossil trunks like threads of quiet ruin. These forms, etched in old wood from sites across Gondwana, chewed away at the hard bonds, their enzymes slicing links that once held carbon locked for ages, releasing it back to air and soil in a steady flow. Enzyme traces in fossils show how fungi broke down wood, using chemicals that fit perfectly, balancing the carbon wheel where build-up matched release. No more wild swings from buried heaps that fed oxygen's rise. This shift locked in a new rhythm, fungi claiming their role as silent keepers, their spread a force on the land, where growth's promise always carried the shadow of swift decay, instincts in every root urging build before the eaters came. Sulfur wove through this too, cycling slow in seas and stones, where pyrite formed in mud and held the gas in check, its breakdown tied to air's hold. Carbon moved in step, buried in swamps or worn from rocks by rains, the geo-carb-sulf model mapping it all through balance sheets that weigh inputs against outs. Equations tie oxygen tight to burial rates over weathering pulls, showing how a small tilt in the ratio, say, more carbon sunk than scraped free, pushes levels up, while even where swings them low, sensitivity so sharp that tiny shifts over eons reshape whole worlds. These formulas, built from isotope marks in layered stone, reveal the era's fragile hold, where sulfur's slow release from pyrite beds added layers to the drop, a creeping change that left creatures adapting to less, their bodies haunted by the memory of plenty now fading into constraint. Bacteria joined the fray in Permian soils, tiny forms swarming through dirt to break down scraps that fungi missed, their work speeding rot in warm spots where moisture clung. These helpers digested bits of leaf and stem, turning them to gas and dust that fed the cycle back, much like in today's tropical woods where rains keep grounds wet and life teems in every handful of earth. Modern forests mirror this, with bacteria churning through fallen logs in humid heat, but Permian versions held a raw edge, soils thinner and harsher under Pangaea's sun, where the breakdown built a barrier against old highs, locking air in bounds that favoured steady oversurge. This microbial push added weight to the shift, a quiet force that shaped lands where life learned to thrive on less, instincts etched with the pull of endurance over excess, a scar from times when abundance slipped away unseen. Fossils carry these echoes clear, Permian resins from scattered sites trapping air in bubbles that mass spec scans peg at 28 to 32% oxygen, pockets of the past held in golden drops where gas stayed sealed through stone. These finds, pulled from layers in regions like those edging ancient seas, offer direct peeks at the era's breath, spectrometry breaking down the mix to show highs that lingered before the fall, a frozen whisper of what filled lungs and fueled fires long gone. Such clues scatter through rock, from Baltic edges to deeper digs, each bubble a capsule of lost balance, haunting the record with proof of air once thick enough to build giants, now thin to echoes that remind of fragile holds. Stability stretched long after, Phanerozoic air swinging between 15 and 30% over vast spans, tied to supercontinents that formed and split in slow dances. These cycles drove the ups and downs, lands joining to bury more or breaking to wear fast, oxygen following the beat like a shadow to the stone, where highs came with crowded worlds and lows with sparse survival. This pattern locked in after Permian turns, no wild peaks returning as decomposers held the line, air settling into rhythms that shaped later life. A legacy where change's slow grind taught adaptation's hard lessons, creatures carrying the weight of past shifts in every breath taken under steadier skies. Earth stayed locked in low oxygen for billions of years before the shift, air thin with gases like methane and carbon dioxide, where early microbes clung to chemical feeds in a world without breath's gift. Cyanobacteria changed that around 2.4 billion years ago in the Great Oxidation Event, their tiny forms splitting water under sun to make energy and spit out oxygen as waste, levels creeping up to 1 or 2% over hundreds of millions of years. This gas built slow at first, binding to iron in seas to form red bands in rock, but then it spilled into air, poisoning old life that saw it as toxin, wiping out vast stretches in a quiet kill that left survivors huddled in dark pockets, instincts forever marked by the sting of change's unseen blade. Later, around 800 million years ago, in the Neoproterozoic, oxygen climbed again to about 15%, tied to more plant-like growth in waters that fed the rise, opening doors for complex cells to form and early animals to stir. This build-up fed bursts of life, but carried a heavy shadow, where higher gas meant faster burns and sharper edges to survival, creatures feeling the pull of new needs that twisted simple existence into tangled webs of hunt and hide, a psychological weight that echoed through evolving forms as they grasped for more in the thickening haze. The Permian sat in this flow, coming after Carboniferous highs of 30% that lingered into its start, air still thick enough to fuel giants, but starting its slide toward 15% before the Triassic dawn. This context lined up with die-offs like Olson's extinction around 270 million years ago, where groups faded in the early Permian heat, a prelude to bigger losses that left lands scarred and quiet, the mind of the biosphere haunted by gaps where life once thrived, instincts urging fill before the void claimed all. After the Permian, levels bounced back in the Cretaceous to 25 or 30%, a peak that powered dinosaurs through their era, massive bodies roaming under skies where oxygen fed endless motion and growth. This high let scales and feathers spread wide, but hid the cost of dependence, where creatures lived on the edge of breath's limit, psychological binds tightening as competition grew fierce in the abundant air, every roar carrying the echo of potential fall. The Cenozoic followed, with a steady drop to today's 21%, air settling into calm after wild swings, mammals rising in the thinner mix with brains sharpened for cunning oversize, a shift that left old giants as bones in stone, their legacy a whisper of what excess once allowed. Tectonics drove much of this. Pangeas split cracking lands apart to let oceans stir and weathering speed. Rains carving rock to pull carbon down and lock it away. Oxygen following the beat of these slow breaks. Photosynthesis rates added their pulse, plants pumping gas out in green waves that rose with land covers spread, but fell when fires or die-offs cut them back. A cycle where life's own work shaped the air it breathed. Instincts in every leaf urging growth against the grind of loss. Weathering feedback sealed the loop, rocks crumbling underwater and roots to suck in gases, balancing highs with lows in a rhythm tied to Earth's deep moves, where each shift carried a psychological toll on forms that adapted or broke under the weight of changing skies. Low oxygen worsened the Permian Triassic wipeout, feeding ocean anoxia where seas turned dead and black, as a 2016 Stanford study tracks through rock clues showing gas drops that starved waters of breath, delaying life's return for millions of years. This anoxia spread like a blanket over depths, killing off swimmers and crawlers in silent waves, a dark grip that left survivors gasping in shallow refuges, their existence haunted by the memory of vast empty blues, instincts forever altered by the choke of what air once gave freely. Labs today bring Permian breaths back to life, synchrotron beams piercing ancient insect tubes to map how tracheae twisted and held air in those old giants. Scans from Argonne's light source show tracheal walls folding like accordions, squeezing oxygen deep into tissues where modern bugs struggle. These images confirm the tube's twists allowed bugs to thrive in thick air, their paths wide for the era's rich flow. Studies on reptiles in high oxygen tanks echo this. Modern alligators growing faster with boosted scales and bones when air hits 30%. Cells swelling with the extra fuel that spurs size and strength. Yet this growth hides an edge. Bodies pushing limits that echo the Permian push toward giants. A drive that once reshaped life but now warns of bounds we test in labs. Fires in those days leapt thresholds we probe today. Tests with damp leaves igniting at 30% oxygen where modern flames fail. Bundles of wet grass spark and spread in sealed rooms, heat rising as gas feeds the burn, showing how Permian woods, even soaked, could blaze from a single strike. This threshold, crossed in chambers at Berkeley and beyond, paints a world where flames ruled wet grounds, ecosystems dancing on the brink of ash. Air then held more weight. Models estimate density 20% higher than now, lifting wings of Permian flyers with ease. Pterygote bugs soared on this thick flow, their beats cutting through gas that buoyed heavy frames, a lift lost as levels thinned over eons. Plants pulsed with this air's gift. Models of Permian growth showing biomass 1.2 times, carboniferous peaks in some spots, though overall the air dried and yields fell. Paleobotany digs reveal forests shifting, leaves thickening against heat while roots dug deeper for scarce water. Seeds sped their change, gymnosperms rising with cones that guarded young in dry winds, evolution quickening as spores faded in the parched lands. Conifers spread cones wide, pollen riding breezes where water once carried life, a leap that locked survival in tough shells. Humans today tuned to 21% oxygen, hemoglobin grabbing gas with curves that shift for the thin air at peaks. Blood cells swell red at heights, carrying more to muscles starved in low flows, efficiency honed over ages for this balance. Hyperbaric dives push this, chambers flooding wounds with pure gas at twice the press, speeding heals for burns and dives gone wrong. Therapy in sealed tubes mends skin and bone where low oxygen stalls, a bridge from lab to bed that saves limbs and lives. Altitudes bite mirrors, Permian lows, breaths short and heads light as gas thins, bodies adapting with thicker blood much like survivors then pushed limits in fading air. Climates now shift oxygen down. Fossil burns draining 0.001% yearly, a slow bleed from fuels that warm seas and thins depths. NASA eyes far worlds for this. Models spotting oxygen as life signs in alien airs, spikes hinting breaths like ours amid stars. Probes scan for O2 builds, false highs from rocks or light ruled out, seeking worlds where gas whispers of hidden greens. Permian holdouts like Lystrosaurus bent to this, burrows hiding from thin skies, adaptability letting them roam where others fell. Modern bugs echo these relics, wings clipped and bodies shrunk from giants' frames. O2s drop and birds rise, scaling down the old lords. If these ties from old air to now's breath stir a quiet call in you for more hidden tales, yet you hold back from joining whisper of time, share softly in the comments what keeps the distance. Your gentle words might draw kindred hearts to subscribe and cherish these echoes together. Permian coal beds in places like Appalachia fuel our lights and machines today. Black layers dug from earth that once trapped the era's green fall, turning ancient sun into power we burn without pause. These seams, pressed from glossopterid remains in vast flats, hold carbon that shaped our world, a quiet draw on the past where digging stirs old breaths back into smoke. This time bent paths for mammals too. Synapsids shedding reptile ways for warm blood and fur, evolution's slow twist through losses that left survivors lean and quick. Instincts honed in the crush of die-offs, where weakness faded and cunning rose. Fossils from the Karoo supergroup in Africa spill these secrets. Stacked bones and prints in red sands telling of herds and hunts. Insights into lives that balanced on oxygen's edge. Each find a window to minds locked in endless watch for the next shift that could end it all. Research pushes on, counting tiny pores on Permian leaves to track carbon dioxide's hold. Stomatal density thinning as gas grew thick. Proxies that map air's past grip on growth. Leaves from digs show these counts low in high CO2 times, a clue to warmth that baked lands dry, pulling back veils on climates long gone. Machine learning sifts igneous rocks now, algorithms chewing through lava layers for oxygen rebuilds. A 2022 Nature paper, laying out how code spots patterns in crystal grains to trace gas flows over eons. reconstructions that sharpen views of highs and lows, where data whispers of balances we upset today. Earth's air flows as life's own make, a living veil shaped by breaths and rots that tie rock to root in endless loops. The biosphere's hand turning gases to tools for survival's game. The Permian bridged this, giants giving ground to diverse forms that filled new spaces, a handover where old scales shrank and fresh lines spread, diversity blooming from the ashes of crisis, a psychological legacy where life's thread wove through breaks without snapping, each strand carrying the weight of what came before in silent strength. At 30% oxygen 260 million years ago, life hung between fresh sparks and breaking points, innovation blooming in the thick air while crisis loomed in every dry wind and fading breath. Whispers of that time still echo in our own, faint calls from stone that shape the air we breathe today. Thank you for staying to the end of this quiet journey through ancient air. Please like, share, and subscribe to Whisper of Time to keep these stories alive, and join us next time for more tales that echo through the ages. Rest well.